let us assume few things before getting into this video. The first one is we are going to build the backend of an application. It can be any application, can be a mobile application, can be a web application, but we are going to build backend of this application. This is our first assumption. So after assuming this, what we need to do is we need to take input from somewhere. Either it can be from user directly. Let's assume that we are going to build backend, right? What we can think is like we are getting data from the front end, and now we need to validate this data and then store this data inside the database. So basically we are getting user related data, like when the user signs up to our application, we get some data in the front end, and let's assume we are getting this data in the back end where we are writing code, and we need to store this data inside the database. So the process between the getting data and storing it in the database, there is some process to write in the code. So we will see this process in this video using structs in Rust. Before getting any further, don't forget to subscribe to this channel for the future episodes of Rust series. Let's start with creating a project. So cargo new, the project name is let's call it as Structs, because we are going to demonstrate structs in this video. So let's call it Structs, and we created Structs. Let's go cd structs. Now let's open the main.rs file and remove this line. Now according to our assumption, we are getting data from front end, and we need to do some kind of validations or store temporarily in the code so that we can push it to the backend. And third thing is push to the database. So these are the three things that that the process contains, but we are not going to do the first thing and the last thing because we don't have a database yet and we are not getting anything from the front end. What we are going to do is we are just going to keep these as comments, and let's assume we will hard code the values whatever we will get from the front end. For the example sake, what we are going to do is we are going to do this second step in this video. Let's start with hard coding some values that we are going to use in this video. Let's say we are taking some user related values when user is trying to sign up in the front end. The first thing is it's going to be the user name, and the second thing is going to be let's call address of the user. Let's say we are only taking these two things, or let's, for simplicity, we call it as city only. Okay, so the first one is name. It's going to be a string, and let's hard code this for now, and I'm calling it as Chiranjeevi. And the second value is going to be the city where the user lives. This is also going to be string, and currently I am living in Bangalore, so let's give Bangalore. So we hard coded name and city like this, and let's say we are using some value, some kind of function here, push like this, which will push the data to the database. Let's assume there is database, and this push function will push it to the database. Let's assume there is no push function right now, but let's assume that if there is a function, it will push to the database. How we are going to use it? If we have these values like name and city, how we are going to push it both to the database so that it will be connected to the same user? Let's say we are getting another user, name 1. Okay, we will do one thing. We will just copy these two and paste it. Let's call it name 1 and city 1, and let's give some Chiru and my hometown Guntur. So if there are two users and we have details of two users like this, how we are going to store? I mean, these two are related to one user and these two are related to another user. How are we going to differentiate which user, which detail is belonging to which user? If we are going to use this function and if we have to give everything like this manually, name, city, how does database know that these both things are belonging to the same user? We can have multiple users using the same name, we can have multiple users living in the same city. Like, how are we going to differentiate between both of them? Here what we can do is we can add a ID. Let ID is going to be anything, like let's do one thing, let's take it as a unsigned integer 128. We don't need 128, but let's give same ID here, ID 1 u128 equal to 1. We have to give IDs like this, and so now what we can do is we can pass ID as well in the push function, so that it will push ID, name, city, all three of them to the database, and we can differentiate each user using these IDs, because IDs generally will be what we call they are unique, so unique for the each user. This is how we can do things. But see, we still passing these things separately, like we are passing ID, name and city like as a different entities, not as a single entity. Let's assume if we have a way that if we can push these values as a single entity like a user, if we can pass like this and the user contains all these three values, it would be better for the database to identify everything as a single entity rather passing each of these separately. Now to pass all these things using a single entity like this, like a user or something, we use structs here. Now that we have understood why we need IDs, basically we need them to identify a user uniquely, because a string name can be repeated, multiple users can have same name, and cities can be repeated because multiple users can reside in the same city. So now let's remove this because this is redundant, and let's have one single user which we are going to store in the database. So as we have said before, let's try to store all these things as a single entity rather than different things, so that we can pass that single entity inside the database rather than all these things separately. So for that, what we can do is we can create a struct. We can do that using this struct keyword. So struct is the keyword which we use to create a struct. So what do we call this struct? We want to call this struct as user because that single entity which will contain all these things is a user. User have all these things, so we want to call it as user. So after giving its name, what we have to do is we have to open the curly braces. So inside these curly braces, what we will do is we will have to specify what are the features that this particular entity will have. What are the features that this particular entity is having here is ID. It's having an ID. ID is a number. So we will give the, sorry, not a number, u128. So this is one thing. And what other it's having? It's having a name. It's going to be a string. And the other thing is city. And this is also a string. Let's put some commas quickly here. Save it. Yeah. Now we have a, what this struct is doing, if you see carefully, it's just giving a blueprint on how an entity should look like. It's showing that a user should look like this. The user should have an ID, the user should have a name, and the user should have a city, and they should be of these types. It's just giving the blueprint on how an entity should look like. So now let's convert our user into a single entity rather than giving all these values separately. What we can do here is, let's call it as user, and it should be of type user struct that we created, equal to user. If we are using this, we don't need to explicitly give the type, but let's keep it like that. So now we have to give three values. If we don't these three values, it will throw an error because it's expecting these three values. The first one is an ID. The ID is 0 in our case. So let's put 0. And next, the thing we have to give is name, and name is Chiranjeevi, this thing. And the last one is we have to give the city, and that is Bangalore. Now we can remove this. Okay, now we have created a single entity called user, which is of type user, and it will have these values. Now we have created a struct. If we want to make some computations based on just one particular feature of that entity, let's say if you want to check if the name is empty or not, and if you want to check city is empty or not, how we can do that? Let's do those temporary validations. We can do that using let's check if the name of the user is empty or not. So for that, what we can do is user dot and the attribute which we want to check, which is name in our case. If this is equal to an empty string, then let's print name is empty. Let's save this and run this. Okay, before running I forgot to change this. It should be like this. Okay, save this. And if you want to also print that we are not going to store this inside, not pushing to db, let's just put this as well, so that we are logging that we are not pushing to db if the user name is empty. So let's run this. Cargo run. Oh, name is empty. Okay, I removed it. Name is empty and not pushing to database because the name is empty. Let's just keep this thing and let's try to run this again, and we should be we are not seeing anything because we are not printing anything if there is name. So this is how we can add validations. This is how we can get the particular attribute out of the struct. If you want to get the id, you can pass it id. If you want the city, you can pass city like this. So it's just you can do however you want. I hope by now you have got an idea what a struct is. So basically, let me reiterate. A struct is a user defined data type. So if you see in our example, there is no data type called user, but we have created it. We have defined how it should look like, and it gives a blueprint. It gives a blueprint on how an entity should look like. There is no data type called user, but we have created it, and we are also saying that it should have an id, it should have a name, it should have a city. So we are giving that a user should have all these three things in order to be a valid user. So this is where we can use structs. Okay, there might be some person shouting on the other side of the video that we should not use IDs like this, and let's see why we shouldn't use IDs like this. Let's try to create another user one, and it is also type user, and let's give an ID of 1 because ID should be unique for each user. That is the reason why we started with IDs in the first place, because name can be repeated and city can be repeated, but ID shouldn't be repeated, so that we can identify a particular user using that ID in the database. So let's try to give some other name here. Let's call Rust, and city. What city do we give? Let's call Guntur, which is my hometown. Okay, save this now. We have both user and user1 like this, and we can push them to the database from here. Let's try to run this once. We can do one thing. Let's print these things. Let's try to print these things. Println user, println and user 1. If we try to run this, it will throw a big error. Can you guess why? And this is not because of the IDs that I have been talking about, but this is about this println lines. Why? The reason is the Rust doesn't know how to parse this thing. This is a user defined data type. Rust doesn't know that we are giving that particular ID, name, city. Like Rust doesn't know how to parse structs at all. So we have to specify some things before running printlns on structs. We need to pass something like this, colon and question mark. Here also colon and question mark. What this specifies is that we are trying to print these things just for the debugging purpose and not the production purpose. So if we do this, we will be able to print this. But even before that, what we have to do is we have to give this an attribute, the struct an attribute that we are going to use this for debug. So what we will do is we will use derive debug. Now if we save this and run this, oops, I think I have forgotten exclamation marks. Save this and run this. Now if you can see, we are getting the output, ID, name, these things. Now we will do one thing. Let's run this again. If we run this again, we are getting the same output, ID 0, ID 1. But when we ran them before, we have already pushed them to the database, right? So database already contains a user with ID 0 and ID 1. And now if we try to run this again, we are again pushing users with ID 0 and ID 1. This will create a conflict in database and it will return an error from the database. So we shouldn't do them. This is the problem if we try to like hard code IDs, or if we use like any random logic for the IDs. There is a high chance that we can repeat an ID. If we repeat an ID, the database will throw an error for sure. Okay, now we know the problem that we can't hard code IDs like this, or we can't even give like numbers like this, and we can't do some incrementations or something like that, because there is a very high chance that we can repeat a number. Now what we can do? We know the problem, but what's the solution? The solution is something called UUID. This UUID is a package or a crate that is available in most languages, which will give us a function, and we can use that function, and it is sure that it will generate a unique string every time, because it uses a date inside that and time inside that while generating the token, while generating the ID. So since it uses that, it's almost guaranteed that it will generate a unique ID every time. So we can use that UUID crate or package for our purpose. So what we can do is you have to go to crates.io, and what you can do is you can search for UUID crate, and it's the first thing. It's a very most used crate in almost any language, because IDs are there in everywhere. So let's see how we can use it. First we have to install that using this command. Let's copy this, and if you use that, it will create something like this in the cargo.toml file. We will see that, and we have to use it like this. We will come back to this. First let's go to VS Code, and we are inside Structs project, and let's just have a look at cargo.toml file. Currently there are no dependencies here. Now let's paste this thing, cargo add UUID, and press enter and see how the cargo.toml changes. It's fetching the crate. Okay, I'll cut this and I'll continue from after it completes fetching. Finally it's done. Like it took around 5+ minutes. Let me know in the comments if it took same time for you as well, if you tried, or is just for me. Okay, anyhow we completed, and if you see in the dependencies, we can see UUID. It's saying version 1.3.0, which is the correct version, and let's close this. We don't need this. And how we can use this, let's go back to the documentation, and if you see here, we can use it like this. First we have to specify that. Okay, let me paste first and let me explain them. Okay, so what it's saying is there is a package called UUID, and use this particular function UUID with capital U, this function from the UUID package. Let's say if you are using multiple packages in your project, and let's say by mistake there is another UUID function in some other package. Rust doesn't know which one to use. It won't even let you use without specifying the package first in the first place. But let's say if there are multiple functions with the same name, and Rust wants to know that you want to use which package, you want to use which function from the which package. So for that we are specifying here UUID function from the UUID package. The first UUID is the package and the second UUID is the function. We have given the line, and what we can do is we can use this function like this. So basically UUID is also not even a function, it's a module inside the package UUID, and new v4 is the function inside the module UUID inside the package this UUID. So that's how it's happening. So we can copy this, and what we can do is instead of giving it like this, what we can do is we can use this, and here also we can use this. But before running it, we have to see that whatever we will get as output is a string. UUID produces a string, not a number. But inside the struct, what we have done is we have given it as a U128. So let's save this now. I hope there shouldn't be any error, and let's run. Oh. What function or associated item is not found in UUID. After few minutes of debugging, I found why it gave that error. The reason was we forgot to do one thing. What we have to do is we have to give this thing inside that cargo.toml file. It is very it's very confusing here. If we add this, it is creating this thing, right? Under the dependencies created this, but if we add what they have given, we have to remove this. So it's a bit confusing, but let's do this thing. Okay, it need these particular things to run that, so that's why it was giving error. Now if we save this, and if we go here, and we need to do one more thing. When we do this function, what it will return is it will return a string literal, but what we are giving a type as here is a string type. So what we have to do is we have to give dot to string function, so that it will convert the string literal into the string, and here as well. Now let's save this, and now let's run the project cargo run. As you can see, it created a very gibberish string, and we are passing it as a ID, and here as well. Now let's try to run this again and see if the IDs are different. Now that's what we are using, that's the reason why we are using UUID, right? We wanted different IDs each time we use that function. So let's run this again, and as you can see, in the previous one it started with C4 and ended with 99, and here it started with 51 and ended with A0. So both these IDs are different from the previous run. So the UUID will make sure that it's giving that a different ID every time when we use this function. You may ask why we are not using string literals and why we are using only strings here. In the last video, what we have concluded that it's better to use string literals when there are multiple combinations of string literals and string types, but why we are not using it here is a question. It's a valid question. So the reason is we need to know something called lifetimes before using string slices inside these structs. So until then we will use strings. When we get to know about lifetimes, we will use string slices at that point of time. That's it for this video, and let's meet again in the next video, in which we are going to discuss about tuple structs and the functions associated with structs using implementations. And please like, share and subscribe to this channel until then, and we will meet in the next video. Bye bye.